Welcome to the tutorial projects within CompoSIDE. The aim of this video is to very quickly allow you to immerse yourself in our modules and workflows. The objective of this project is to define and analyze a basic I-beam and generate a basic bill of material including weight and cost. This tutorial is broken into distinctive sections. We encourage you to follow it at your own pace, replicating the design steps. Let's start in project space. This is where your projects and product data are stored, including bill of material settings and analysis settings. Duplicate the sample project by right-clicking on the project and select it in the Project Navigator. We can rename this project by selecting Edit Settings, viewed by right-clicking on the project. Create a product to organize your design work by expanding the project. Let's start by selecting our materials to be used in CompoSIDE. For this, we go into CMDB. CompoSIDE gives you a library of generic materials free to use, or you can create your own materials and store them in your company library. The material data is data provided by CompoSIDE which can be used across your projects. Company materials are your private materials library. Project materials are materials specifically used within your project. For this beam panel, I would like to have a shear web comprising of two different plies, a carbon UD and a carbon biaxial ply, with a core of 100 kilo density. You can use the filter to quickly navigate through the database. To assign materials, simply drag and drop them into the project's materials folder. Now you're ready to start laminate design in LaminaSpace. We can close the CMDB window and access the LaminaSpace module. On the left tree window, expand the laminate folder to see your laminate groups and laminate families. You can also access global loads from this tree, but let's skip the global loads now. To create a laminate, right-click on Laminates and select Create Laminate Family. The laminate family creator will appear and prompt for a laminate family name, fiber type, and manufacturing type. Fiber type and manufacturing types are used downstream, defining usage and wastage factors, and also certification requirements. For this project, standard settings will be applied. To learn more about how to define your own usage and wastage factors, please refer to the Bill of Materials setting tutorial. In the beam, the shear web is defined as a sandwich laminate, and the capping flanges will use materials we have defined in our project materials. The stack editor is ready to add plies or cores. Let's create a ply by clicking on the green Add Ply button at the top right. Select the material, number of plies, and orientation. Click Add when you're done. Now we have our outer skin and core defined, we can define the sequence type. For this example, we'll use symmetric odd. Now you have your laminate defined, we can move into analyzing the materials by using it in a 2D section or a 3D component. For this example, we will need to define our I-beam section before we moved on to 3D analysis. Close LaminaSpace and open Section Space. Section Space will open with your entire project defined sections and global loads in the tree. Right-click on Beam Sections and create Beam Section. Name the section and define the section type. The section type is dependent on your section geometry. CompoSIDE supports both thin-walled and solid sections. In this example, we will analyze a thin-walled section. Thin-walled sections have more comprehensive results, but have limitations when the laminate is relatively thick. We'll start by creating a section. We have the options to do import geometry, generate it from a template, or define it manually. We will use the geometry template tool to create our section. I found this tool helpful and it saves me a lot of time. Go to section and create geometry from template. The template tool will open and give me a choice of predefined sections in the drop-down list. Select I-beam and define a width, height and capping width of 200 mm. Then click Create. Now our geometry is defined, we need to apply materials or laminates to our section. Let's define our elements, starting with the shear web, applying the laminate you defined earlier in laminate space. Select Create Layered Section element from the bottom toolbar. Select the shear web line and move into the stack. Click Add Laminate Family to choose your laminate family. You can also add a sublaminate if you've defined one. Press Add. Hit Save and Close to view your laminate. Next we have to define the capping. We will assume that we have the same number of plies in the top capping and the bottom capping. This way we can define it all together. Create a layered section element again, but this time we will select the element type as reinforcement and select the remaining geometry. Move on to the Stack tab. This time we will define it as a material. Select the material, our unidirectional carbon. We will add 20 plies, all at an angle of 0. Click Add and hit Save and Close. Once you've created this section, you can apply loads, analyze the allowable loads, or export section properties. View the dedicated section space tutorials for more information. We will leave this section out as we're going to use this beam to design a 3D beam in FE space, and can bring in the loads to undertake section analysis later. Save and close section space and move into FE space. In the FE space module, we use our product, which you defined earlier in project space. Expand this to see the folder structure. You can add as many folders as you require to any product, available by right-clicking on the project or topology group. For now, we'll use the folder name group to keep our FE model in. Right-click and create FE model. Let's call it I-beam. We can stop this model from being automatically taken into the bill of materials or analysis report by deselecting the tick boxes below the name. Hit Save and the FE model editor will appear. Similarly to section space, in FE space we can create geometry by importing it, manually defining it, or generate it for a template. For beams it's much simpler to create it manually. Let's create a beam 2000 mm long, simply supported with a point load in the middle. We will start by creating the geometry. Select Create Sketch from the bottom toolbar and choose the reference plane as XY. Click Save and Close to activate the sketch. We need to create 2 points. Select Create Point. One at 0 and one at 2000 mm along the x-axis. You can keep the window open by clicking Save instead of Save and Close. Join these 2 points with the line by selecting Create Line Segment, and select the origin point and then the second point by clicking on them one after the other. Hit save and close on the segment editor. Once you're done, hit release from sketch, the red button in the plane and sketch navigator. You can rotate the model by holding the right mouse button and moving the mouse, and zoom by using the scroll button. Next we have to bring in our section properties. Right click on the section properties folder and select create properties. Here you can create manual properties or import them from section space. Click on the From Section Space tab and select the reference beam. Your section properties will appear in the editor. You can edit the section in this window by clicking Edit. To return to FE Space, click Go Back to Model. It will warn you to recalculate your load case if you have changed your section. Hit Save and Close when you're done. Next we have to apply the beam to our section. Choose Create Beam from the bottom toolbar. Select the edge and move on to the Properties tab. You can select as many edges as you need. You can select your predefined section in here, or create a new section. We'll create our beam properties by selecting it from the drop-down menu. In the FE tab you can control your element size, but the default settings are good enough for now. Hit Save and Close when you're done. To visualize the beam, go into the View menu, Beam Visualization, and hit Full Cross-Section Visualization. Now we have our geometry defined, we have to define our load case. First, let's create our boundary conditions. As this is a simply supported beam, we'll create 2 point boundary conditions by clicking Point Boundary Conditions in the bottom toolbar. Select both points and click Fix Displacement. You can do this manually by clicking on the tick boxes. Hit Save and Close. Expand the Loads and Boundary Conditions folder to view all your applied loads and boundary conditions. Next we will apply a point load to the center of the beam. To do this we have to turn off our beam geometry. Turn off layer 3 in the top toolbar. Right click on the line and select Add Internal Point. Next, define the position of our point by a function of the length, actual distance along the beam, or by dragging the slider. Select a function of the length as 0.5. Click Add when you're done. You will see a light blue point appear. Next we have to create a load. Click Create Point Load from the bottom toolbar. Select the point where you want the load to be applied, and apply a working load of -100 kN in FZ to it. We want to analyze it under an ultimate load. Select Ultimate in the Output Load Level drop-down menu. This will apply a factor of 2.7 to it. Hit Save and Close to view your point load. Click on the point load in the tree to visualize it. Now we have our geometry, boundary conditions, and loads defined, we need to create a load case. Select Create Load Case in the bottom tree. In here you can select your boundary conditions, loads, analysis type including static, modal, and buckling. Bring your point boundary conditions and point load from the available to load case. Hit Save and Close when you're done. You can view your load case by expanding load cases and clicking on the load case. Mesh the model. Right click on the load case and select Calculate. The task will be sent to our solver. The results will be stored and available for you to view in the tree. You can also lock the task and rename the task using the padlock icon and right-click. Click on the task to view the results. You will see the deflection results. Open the result settings from the bottom toolbar. In here you can view nodal, element and reserve factor results. For now we will just check the beam reserve factors. Hit Calculate and select the Global Minimum Reserve Factor tick box. From here, you can optimize your laminate geometry by using the Review and Section Space button. For now though, we're okay with the results, so we will return back to FE Space. Exit the results by going back into Edit mode on the bottom toolbar. Save the model and exit. Now we have our I-beam designed and analysed, we're going to create a bill of materials. Exit FE Space and open the BOMGen module. You will see your products in the first window. This will allow you to organise your project into different products, allowing versioning or a quick comparison between two or more products. Click Generate to generate a bill of materials for your product. You can see the total product material quantities and cost in the main screen. This has been automatically generated from the FE model's mesh. If you make a modification to an element, you can bring in the latest data by clicking the orange Update with Source button at the top right. Expand the group folder in the tree menu and right-click on it. You will see many functionalities within BOMGen, including manual element creation, such as surface elements, beams, bondings and reinforcements. We will generate a laminate table and BOMGen report based on our FE model. Right-click on the group and select Export Laminate Table. This will allow you to download the laminate table with the weight and cost, where you can copy and paste it into an engineering drawing. We can generate a report within CompoSIDE with a standard format, allowing you to share and version the product's bill of materials with a revision number and date. We will go into Report Space to do this. Close BOMGen and select the Report Space module. Right-click on the BOMGen's report folder. Right-click on the BOMGen Reports folder and click Create Report. Give the report a name, select the product and choose the report template. You can edit or create your own templates within Report Space. Click Save and the report will be generated. You can share the report by generating a PDF or by sharing a web link. The report is saved in your CompoSIDE environment and will remain available for your records. In this tutorial we have covered basic projects and product management, projects and material management, laminate creation, 2D section creation through to 3D beam design, basic BOM definition with creation of laminate table, and a basic bill of materials report. We hope this was useful. If you have any questions, please message us through the chat at the bottom right of your environment.